Good morning dear students, welcome to my video. Today we are going to start a new chapter, Squares and Square Roots. In this chapter we are going to learn what is a square number, properties of square numbers, some patterns with square numbers, then square root, some few methods to find the square root. So first we will deal with squares. So what comes in your mind when you think about a square? Yes, a square is a geometrical figure, see this here, with all the sides equal and each angle 90 degree, equal angles. So this only it will come to your mind when you will think about squares. That is a geometrical figure with all the sides equal and all the angles equal. So how do we find the area of a square? Suppose this is a square of 1 centimeter each side. 1 centimeter. So how you will find the area of this square? Area is equal to side into side. This formula you have already learned, side into side. So here it is, since it is 1 centimeter side, it is 1 into 1. Or you can write that it is 1 square centimeter. Unit of area is square centimeter. Now see this square. The side of the given square is 2 centimeter each. All the sides equal 2 centimeter. What will be the area of that square? So area A is equal to 2 into 2, side into side, 2 into 2, or you can write it as 4 square centimeter. Similarly, if this is a square of side 4 centimeter, all the sides 4 centimeter, then what will be the area? Area is equal to 4 into 4, side into side, it is 16 square centimeter. So any side if it is given also, you can find the area of that square by multiplying the side into side or side 2 times. Or in general, if a square is having side n centimeter, then area is equal to n into n. So what is n into n? N into n is n square. So what is 1 into 1? That is 1 square. What is 2 into 2? It is 2 square. And what is 4 into 4? It is 4 square. So in general, if you are saying means a square having n centimeter side, then area is n square centimeter. So what we were doing here to find the area of a square? We were primarily multiplying the number by itself. The same number you were multiplying. 1 into 1, 4 into 4, 2 into 2, like that. N into n in general. So same number 2 times we were multiplying. So how big the square is also doesn't matter. The area would be side into side only. Side is the length of the side. So length of the side 2 times you are multiplying, you will get the area. So whenever you are multiplying the number by itself, you are getting the square of that number. See, n square, 4 square, 1 square, 2 square, etc. So in this chapter, our focus is not on the geometrical side of the square, rather our focus is on the squares of the number. So we are seeing only the squares of the number, that is 2 square, 1 square, 4 square, etc. Any number square, 5 square, 10 square, 100 square, or in general n square. Here I have written the squares of numbers from 1 to 10. So 1 square is 1 only, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81 and 10 square 100. So what are these numbers called? These numbers, answers. What are they called? These numbers are called square numbers. Square numbers. Why are they called like that? Because we are getting those numbers by squaring the same number 2 times. For example, if we want to get 16, see here 16. How many times we have to multiply 4? We have to multiply 4 2 times. Similarly, any number if you take also, that number to get, you have to multiply a number 2 times. So they are called square numbers. There is a special name for these numbers 1, 4, 9, 16, 25. These numbers, they are called perfect square numbers also. Perfect squares. Perfect squares. So what are perfect square numbers? Whenever a number is multiplied by itself, we will get a perfect square numbers. So that is, a number multiplied by itself, we get perfect squares. Perfect squares and square numbers both are same only. So now you understood that any integer multiplied to itself gives a perfect square number. So whichever the number is if it is bigger number or smaller number, doesn't matter. 800 into 800, how much it will come? 6,40,000. So like that, how much ever the number is bigger also, doesn't matter. You can find the square of the number by multiplying the same number 2 times. Now I will ask you one question. Is it all numbers perfect squares? No, it is not perfect square numbers. So which are non-perfect square numbers? Let us see that what are non-perfect square numbers. So non-perfect square numbers are the numbers which are not perfect squares. Where do they lie? If you just closely examine continuous perfect squares right from the beginning, that is from 1, 4, 9, 16, etc. Right from the beginning if you examine, see 1 square is 1, 2 square is 4. So 1 and 2 continuous numbers you have taken. Answers are 1 and 4. So in between 1 and 4, how many numbers are there? In between 1 and 4, 2 and 3 are there. So this side it is 1 square and 2 square, which is continuous numbers. But here answers are 1 and 4, in between 2 and 3 are there. Next two continuous numbers you take 2 and 3. They are also continuous only. Answers are 2 square it is 4 and 3 square it is 9. In between 4 and 9, how many numbers are there? 5, 6, 7, 8. So 2, 3 are non-perfect square numbers. Non-perfect squares. This is also same. Non-perfect only. 5, 6, 7, 8. So next two consecutive numbers you take 3 and 4. Their square is 9 and 16. In between 9 and 16, how many numbers are there? 10, 11, 12, 13, 14, 15. These all are non-perfect square numbers. So in between 9 and 16, 10, 11, 12, 13, 14, 15 non-perfect square numbers are there. This is continuous in between 3 and 4, 3 square and 4 square. That is in between 9 and 16, 1, 2, 3, 4, 5, 6. 6 non-perfect square numbers are there. So in between 1 and 2 or 1 square and 2 square, 2 non-perfect squares are there. In between 2 and 3, that is 4 and 2 square and 3 square, that is 4 and 9, there are 4 non-perfect squares are there. In between 3 square and 4 square, that is 9 and 16, there are 6 non-perfect squares are there. So that is in between two perfect square numbers, you will get non-perfect square numbers. From these, what can you say about this? As the value increases, value of the perfect square increases, do you notice something? See here, in between 1 square and 2 square, 2 non-perfect squares. In between 2 square and 3 square, there are 4 non-perfect square numbers. In between 3 square and 4 square, there are 6 non-perfect square numbers. What do you observe there? That is, the number of non-perfect squares also will be increasing if the numbers are increasing. So basically, as the value increasing, non-perfect square numbers between them are also increasing. Do you think if there is a fixed number of non-perfect square exists between two consecutive perfect squares? We'll see that. Next is that topic only. We'll see that. In between 1 square and 2 square, there are 2 non-perfect squares. In between 2 square and 3 square, there are 4 non-perfect squares. In between 3 square and 4 square, there are 6 non-perfect squares. This 2 you can write it as 2 into 1. This 4 you can write 2 into 2. 6 you can write 2 into 3. Like that, in between 8 square, etc. you can put 8 square and 9 square. How many non-perfect squares will be there? Can you just tell me without counting? See, here it is 1 square and 2 square. So 2 into 1. 1 is here. Next one, in between 2 square and 3 square, 2 into 2. Next, in between 3 square and 4 square, it is 2 into 3. So this number multiplied by 2, how much it's coming? That many non-perfect square numbers will be there. So how you will write this one? 8 square and 9 square, that means this number you have to take. That is 2 into 8. 16 non-perfect square numbers will be there in between 8 square and 9 square. So like that, if it is 10 square and 11 square, how many non-perfect square numbers will be there? That is 10 into 2 or 2 into 10, 20 non-perfect squares numbers will be there. Or in general, you can say, in general if you are taking, if in between n square and n plus 1, I told you consecutive numbers you should take 10, 11, 8, 9, 3, 4, 2, 3 like that. Continuous numbers you should take. So in between n square and n plus 1 the whole square, there are how many numbers will be there? 2 into n, that is 2n non-perfect square numbers will be there. So this is the formula to find the number of non-perfect square numbers in between two consecutive square numbers. So that is, the first point is, between square of numbers n and n plus 1, there are 2n non-perfect square numbers exist. So this is one important point, you have to remember that. So 2 points now we have learned. What is a perfect square number? That is, an integer multiplied to itself gives a perfect square number. Second one is, between square of any two numbers, there are 2n non-perfect square number exist. Or between square numbers n and n plus 1, there are 2n non-perfect square numbers exist. So next topic is properties of perfect square numbers. What are the properties? First one, all perfect squares unit place digit will be 0 or 1 or 4 or 5 or 6 or 9. We will take the example of numbers from 1 to 10. See here, see 1 to 10, all the perfect square numbers I have written. See their answer, last digit you see or unit place digit you see 1, 4, 9, 6, 5, 6, 9, 4, 1, 0. So here we have written all those numbers only 1, 4, 0, 1, 4, 5, 6 or 9. These numbers only will come in the units place digit. Do you have any perfect square number where the number ends in 2 or 3 or 7? No, there is no number ending with other than these numbers. But how can you conclude that any number, if you take also, its square will end only in these digits, that is 0, 1, 4, 5, 6 or 9, by looking the first 10 natural numbers? Let us consider the square of some bigger number. There are infinite numbers, big, small, any varieties of numbers are there. We will take some few bigger numbers. So for example, one 2-digit number 82, one 3-digit number 139, one 5-digit number 64,368. So three types of numbers we have taken: 2-digit number, 3-digit number and 5-digit number. Square of 82, square of these numbers all will be a perfect square number only. Square of 82 means 82 into 82, right? So the unit place digit, you see, it is 2. So that means when we will multiply 82 into 82, you have to multiply this unit place digit first, 2 into 2. So the answer will be 2 into 2 is equal to 4. That means when you will multiply 82 into 82, the product what you will get, that number's unit place digit will be 4. So by similarly 139, if you take 139 into 139 is a perfect square number. So 139 into 139, unit place digit is 9. So what is 9 into 9? It is 81. What is the unit place digit there? 1. So that 1 only will come when you will multiply 139 into 139, the last digit in the answer. So to find the last digit, only you have to multiply the last digit of the number or unit place digit of the number 2 times. You multiply what answer you are getting, that last digit only will come as the ending digit of the given number square. So here last digit is 8. So 8 into 8, it is 64. So 4 is the ending number or ending digit. So what will be the square of this number's ending digit? It is 4 only. So how much ever big the number is also doesn't matter. The unit place digit will be the number from 0 to 1 among the number from 0 to 9. So that the last digit will decide the last number of the perfect square number. So only it's not possible that a perfect square number can have some number other than the given numbers 0, 1, 4, 5, 6 or 9. Because any number if you take also, the unit place digit will be any one of the digits 0 to 9. 0 to 9 numbers are called digits. So a few examples I will show you. 87. 87 into 87. What will be the ending digit of this or unit place digit? 7 sevens are 49. 9 will be the ending digit of this perfect square number. That number other than that number it will be the here, but ending digit only we are seeing. Ending digit will be 9 because 7 sevens are 49. That ending number is 9. Similarly, any number you take, 134 into 134. You tell me what will be the ending digit of this answer. Many numbers will be there. Last digit will be 4 4s are 16. In that 16, last digit is 6. So 6 only will come as the ending digit of this perfect square number. Hope you understood, children. Now I will ask you one question. If a number has 0 in its unit place, then its square ends in which number? You know that 0 into 0 is 0 only. Or 10 into 10, you see, last digit is 0. So it is 100 answer. So digit ends with 0 only. So if any number has 0 in its unit place, then the square ends in 0 only. That is the second property of square number. That is, if a number has 0 in its units place, then its square ends in 0 only. So, it doesn't matter how big the number is or how small the number is, how many digits are present in that number also, but if the number is ending with 0, then the square number also will be ending with 0 only. For example, you take 40 into 40. The number is ending with 0. 4 fours are 16 and 2 zeros you have to put. This is the easy multiplication. Number part you multiply. How many zeros are there? You have to put the zeros there. So, what is the number ending in the perfect square number of 1600? 0 only. So, wherever 0 comes in the unit place digit, then the perfect square will have 0 in its units place only. Next rule is, if a number has 1 or 9 in its units place, then its square ends in 1. These are all only rules, no need to memorize this. So, for example, 31 square. 31 square is 341. See the number here 31, 1 is the unit place digit. So, in the perfect square number 341 also is ending with 1 only. So, if the number has 1 in its unit place, the square ends in 1. Another number with 9 you just select 329. So, 329 square. The value will be ending with 9 9s are 81. So, 1 will be the ending digit. So, if a number has 1 or 9 in its unit place, then its square ends in 1 only. Next rule is, if a number has 2 or 8 in its unit place, then the square ends in 4. So, 2 2s are 4, 8 8s are 64. That is the reason behind that. For example, 32 square. 32 square, last digit is 2. So, number will be ending in 4. 12 square, 144. See 2 square, so 4 it will come. Next 48. If you take 48 square, the last digit will be 8 8s are 64. So, 4 will be the ending digit of the perfect square number. So, this is the way how you will find the last unit place digit in a perfect square number. Next rule is, if a number has 3 or 7 in its units place digit, then its square ends in 9. Why it is like that? Because 3 3s are 9 and 7 7s are 49. Ending digit is 9. So, example, 13 square is 169. See 3 here, so 3 square 9 will come. Similarly, 47 square. So, that number ends with 7. So, 7 7s are 49. The last digit will be 9 only. Next rule is, if the number has 4 or 6 in its units place, then its square ends in 6. Because 4 4s are 16 and 6 6 are 36. Ending digit is 6. Example, 14 square, it is 196. See 4 is the last digit. So, here in the perfect square ending digit is 6. Similarly, 26 square, it is 676. So, here also see the ending digit 6 square is 36. So, ending digit is 6 only. Last rule is, if a number has 5 in its units place, then its square ends in 5 only. That 25 into 25, 25 square is 625. See here it is ending with 5. So, in the perfect square also ending with 5 only. So, you no need to memorize all these things. I am just telling you all these kind of pattern exist. So, only thing is, you all knows the square of the digits. So, as long as you know this, you can write the ending digit of the perfect square number. Hope you understood, children. Now, I will give some homework question. So, these are the homework sums, children. Exercise 6.1. What will be the unit digit of the squares of the following numbers? So, unit place digit of the number you should see. That number's square number's last digit will be the answer. If 0 comes, it is 0 only. So, the following are obviously non-perfect squares. Give reason. So this one you have to draw columns and write the reason. 2 columns you make, number you write first and then reason you write. First number ends with 7. So the numbers ending with 0, 1, 4, 5, 6, 9. They are perfect square numbers. Other than that, if it comes, it is not a perfect square number. So 7, it is not a perfect square number. So 3, 8, 8, 2, 2. So that reason you have to write. So hope you understood, children. Practice all the sums. Thank you, children.